When we talk about the form of a limit, we're talking about a limit of a function that's made from two other functions combined by addition, subtraction, multiplication, division, or exponentiation. It's the same idea that we used when talking about limit laws. Let's define form by example. Let h be f plus g. If the limit of f at a is 0 and the limit of g at a is infinity, then we say that the limit of h at a has the form 0 plus infinity. So the form is determined by the individual limits of the two functions that make up h. Similarly, if h is f divided by g, and the limits of f and g are 1 and infinity respectively, then the limit of h has the form 1 over infinity. Note that we're not saying that the limit equals 1 over infinity. In some cases, limits are equal to their forms, but not in all. Nevertheless, the form can often tell us everything we need to know about a limit. A determined form is a form of a limit that allows us to determine the limit without any other information. For example, consider the limit as x approaches 0 of x plus 2 divided by x squared plus 3. The form of this limit is 2 over 3, and the limit law for quotients tells us that the limit is equal to 2/3. We only needed to know the limits of the numerator and denominator. In other words, we just needed to know the form. That's the essence of a determined form. Let's look at another example. Consider the limit as x approaches 0 of x over cosecant x squared. Here's the graph of cosecant x squared in case you've forgotten, from which we can see that the limit of the denominator of f is infinity. This means that the form of the limit is 0 over infinity. We can't apply a limit law here because the limit of the denominator doesn't exist. Nevertheless, we can still determine the limit just from the form 0 over infinity, because the ratio of x and cosecant x squared must go to 0. You can verify this using the definition of a limit. We should note that the form of a limit is dependent on the manner in which it's written. For example, these two limits have forms 0 over 0 and 0 times infinity, respectively. A form that's not determined is an undetermined form. For example, the form 0 over 0 tells us nothing at all about the value of the limit. Each of the following four functions yields the same form when taking the limit as x approaches 0, but they all have different limits. And any other limits possible also. Limits with undetermined forms must be treated on a case-by-case basis. I'll leave you with two questions. What, if anything, does the form infinity over infinity tell us? And what, if anything, does the form infinity over 0 tell us?